Hi everyone and welcome to the, we're already to part 7 of the Eurofly 3 tutorial series. We're almost halfway through and today, as I promised, we'll finally walk through the cockpit of the airplane and we'll take a look at all its properties and what everything means. So I'm currently in the main menu. I'm going to choose
schedule free flights.
Free flights here.
Free flight dialog.
And I'll make use of the rental.
Filter edit blank. Rental offer combo.
Rental service.
Airbus A380.
And we're going to choose one of the largest airplanes because obviously not all the planes have the same systems and the same equipment and the same properties. So I would like to be able to show you as many of its properties as I possibly can. So if I now press enter on the Airbus A380,
200
steering controls
window.
ready.
We are now seated in the cockpit, and if I were to press tab here, we could actually cycle through different areas of the user interface here, but none of them are available yet because we haven't activated any of the plane systems yet. But for example, besides the actual cockpit and besides the steering controls themselves, if we did have the plane turned on and if we pressed tab, we would be able to see the communicator panel where we could talk to other pilots, or we could see the navigation panel where we could have our waypoints displayed and we could look at them if we have entered any into our navigation system, or there would also be the Atlas panel where if we ever wanted to take a look at the map at any point during our flight to find a particular location in the world before we reach it, we would then be able to look at all of that here. But first of all, we are going to focus especially on the airplane properties here, which we can bring up with Control Enter.
Combo box pilot Lucas Hosnittel 1 collapsed.
And there's a quite extensive list in here, which we'll gradually go through item by item. The first thing we can learn here is who we even are as a pilot and our level. Next, we're told our flight code, or rather our call sign,
SKFRE 695, free flight.
And we're told that it's a free flight. In Eurofly 3, every flight has its own unique call sign, and we can actually even differentiate between the various types of flights by the first number of that flight. So, for instance, in this case, we've been told that our call sign is SKFRE 695.
SKFRE 695, free flight.
And that it's a free flight. In Eurofly 3, free flights always begin with the number 6, so we can already tell, even by looking at the first number of the flight, which type it is. Other types of flights would start with a different number. Next is the type of the airplane.
Airbus A380.
So Airbus A380 in this case.
Transport plane jet plane 3, rented.
There's a lot of information about the plane's type and category. All of this is on this one single line because we can have different kinds of airplanes in Eurofly 3 besides just the category itself. We can have propeller planes or jet planes in terms of their propulsion. Then we can have either transport planes or business planes or combined both transport and business planes. Then there's the category, and the planes can also have different ownership in terms of whether they're mine or whether they're company planes. So we can learn all of this on this one single line. So in the case of this particular Airbus A380, we can find out that it's a
transport plane jet plane 3, rented.
That it's a transport jet plane of category 3 and that it's rented, meaning that if we do perform a flight with this Airbus, our own personal fleet is not going to change in any way. It's a certified plane, meaning that it's valid property of the company
certificate
and that we can fly with it.
Pushback required.
This particular airplane requires pushback. That's because airplanes are actually not able to move in a reverse on their own. So if you get into a situation where you've taxied too far along the taxiway with your airplane and you've gone, for instance, all the way into the hangar or into a gate where in fact you just wanted to stop before that, you will need to actually contact the tower and ask them for pushback to dispatch the special pushback tractor for you to get you out of that spot. So if your airplane requires pushback, you will only be able to choose such airports that do actually offer this service. You shouldn't be landing at an airport that doesn't provide pushback if your plane requires it. So that's why the next line is
Condition 100%.
Condition. In this case, it's 100%. That's because in Eurofly 3, not all the planes necessarily have to be in the same shape all the time. You know, planes get older, they wear down with use, or something can go wrong, or you might have crashed with the plane before. So that's why it's important to pay attention to this line, to this property in this dialog before you actually take off with the plane.
Last system check, none.
We can hear that no system check has ever been performed on this plane yet. The tool which makes it possible for us to perform a system check on the plane is launched with Control-Shift-Y. So I'm now going to escape out of the Properties dialog.
Dashboard window.
And I'm going to press Control-Shift-Y.
Starting system check.
And now the check has been performed, so I'm going to enter the properties again with Control-Enter.
Combo box pilot Lucas Hosnittel, 1, collapsed. Pushback condition, last condition 100%. Last system check, now.
The last system check has been performed just now.
System check, all systems are working correctly.
And the results are that all systems are working correctly, which is amazing because only now I can be certain that it's actually safe for me to perform this flight. If the condition was less than 100%, which is inevitably going to happen over time, or if one of the systems was not working correctly, then we would first need to ask the tower for repairs before we could take off. Of course, in that case, we would also see exactly which systems are not working correctly here.
Number of seats, 615.
The next thing we learn about this airplane is that it has 615 seats in total.
Number of passengers, 0.
And that there are currently 0 passengers on board.
Wingspan, 79 m.
The wingspan in meters.
Length, 73 m.
The total length of the plane in meters.
Base weight, 488 t.
And the base weight is 488 tons.
Current weight, 488,0 t.
The current weight, which obviously changes depending on how much fuel we've loaded and how many passengers we've boarded.
Cruising speed, 945 kilometers.
This is the average cruising speed, which can also, of course, be a little bit lower or a little bit higher.
Maximum cruising range, 15,700 kilometers.
This is how far we are approximately able to fly in one go.
Maximum cruising altitude, 13,100 m.
The maximum altitude at which it's safe to fly with this plane.
Flap positions, 0/4.
Flap positions. Let's now talk a bit about two systems that are really important for planes, and these are the flaps and the spoilers. They're both located on the wings of the plane, and they increase its overall surface or size. The flaps do that in the downward direction, and the spoilers do that in the upward direction, and they both essentially work in contradiction to each other. The flaps are supposed to increase the lift of the plane, and in that way they help it get airborne or remain airborne even at low speeds, whereas the spoilers decrease the lift, and in that way they help the plane to brake or to slow down, to decrease its speed. In practice, it works in the way that whenever we're about to take off, we have to set the flaps to the minimum required position for takeoff. in all cases, well, maybe with the exception of like 1 or 2 planes that do not have the flaps at all. But if a plane does have the flaps, which, like I said, the huge majority of them do, we always have to set the flaps as specified here in the properties, because if we don't, then we wouldn't be able to take off without the flaps at all. Both the flaps and the spoilers can be extended in several different positions. Like I was saying, the flaps are extended downwards on the wing, whereas the spoilers are extended upwards on the wing. And how many positions it is for each respective plane is exactly what the line where we're currently at tells us.
Map flap positions 0/4.
This tells us that this plane of ours has 4 possible flap positions, and they are currently set to position 0. So at the moment, they're lowered all the way inside the wing. Later, we'll see that there's a minimum required position for the flaps for takeoff, like I was saying. So when we're about to take off, we're going to have to find that line and set the flaps correspondingly. So, for example, to position 1. And thanks to that, we'll be able to take off. Our plane will be able to lift up from the ground. Once we've taken off, we then need to lower the flaps again. Because if we forgot to do that and the plane was picking up more and more speed, the flaps could get damaged eventually after a while. So it's a good idea to fly with the flaps extended only at the speeds where they're needed. So at low speeds, when taking off or before taking off, or when we're about to land again. In that case, we need to extend the flaps again to the required position for landing so that they can help us stay airborne at these low speeds, because without the flaps in this case, we wouldn't be able to maintain speed and lift, and we would stall and the plane would crash. But if we didn't, like I said, if we didn't retract the flaps after takeoff, they could get damaged, and that would mean that we may not even be able to land afterwards. So it is not safe practice to keep flying with the flaps extended after takeoff, but before we are about to land. So before takeoff, to sum it up, we extend the flaps to the required position for takeoff. After we've taken off, after we've been told that the takeoff has been successful, we lower the flaps again, and we extend them again before we're about to land, this time obviously into the minimum required position for landing as specified here in the plane properties. Because if we were trying to slow down to the required landing speed without extending the flaps, we would find out that we're not able to maintain that speed. We would be, in case of category 2 and 3 planes, we would be warned of an imminent stall, and we wouldn't be having enough lift at such a low speed, and we would just start stalling and we'd be falling towards the ground. Whereas if we do extend the flaps for landing, it'll help us slow down to that low speed which is required for landing, because like I was saying, the flaps increase the lift and thus help the plane to stay airborne at such low speeds. We extend and lower the flaps with the Control F keystroke. Control is lower down on the keyboard than the Shift key is, so that should hopefully help us remember that more easily. Because we use Shift F to extend or lower the spoilers. When we press Control F or Shift F, we are in an edit field where we are asked to put in a number for that respective flap or spoiler position that we want to extend them to. And the spoilers are also extended or lowered, but like I was saying, whereas the flaps increase the surface of the wing in a downward direction, the spoilers do so in an upward direction. They are located up on the wing. And whereas the flaps help us to keep lift and keep speed and stay airborne, the spoilers help the plane to brake better or to slow down better, to lose speed faster. So we don't use the spoilers while airborne, but we use them while on the ground, when we've just touched down, in order to help us increase the plane's resistance to the surrounding airflow and to brake faster. So let's take a look at these two lines here in the properties about the flaps and the spoilers.
Max flap.
And we learn
flap positions 0/4.
that the flaps are currently at position 0, meaning lowered all the way, out of the 4 possible positions in which they could be extended.
Spoiler positions 0/4.
And the spoiler positions are the same, 0/4, meaning 0, they're currently lowered all the way, but they could be extended all the way up to position 4. One more thing I need to mention about the spoilers is that the small planes don't even have them at all. So specifically in Eurofly 3 here, it's only the category 2 and 3 planes that do have the spoilers. So the spoilers influence our braking distance. So since we extend them only when on the ground, after having landed at a high speed, that's why we need to work with them very carefully, because the more we extend them, the shorter our braking distance is going to be, and the faster we are going to be able to get to a full stop or to a very low speed. Or if we extend them just a little bit, just maybe like to position 1 or 2, the braking distance would have been much longer in that case. But the flaps essentially do the same thing. They also, besides keeping us airborne and increasing lift, they also affect our braking distance. So if we extended them all the way to 4 in this case for takeoff, well, it would obviously take us longer to take off and to gain the required takeoff speed, because the surface of our wing would be larger in the downward direction. They would produce more resistance to the airflow around the plane, so the takeoff runway would actually be longer. The takeoff runway length required would be longer, so the takeoff would be slower. But we can't afford to be taking off without the flaps extended at all, because we would not be able to take off at all in that case. So that's why the minimum required flap position for takeoff is usually what's recommended and what's best for an ideal takeoff.
Takeoff speed 263 kilometers. Landing speed 263 kilometers. Stall speed 323 kilometers.
Now we're learning about the default takeoff speed, landing speed, and stall speed for the plane. Let's pay attention to one seeming discrepancy here.
Landing takeoff speed 263
the
kilometers.
Takeoff speed is 263 kilometers.
Landing speed 263
the landing
kilometers.
speed is 263 kilometers as well.
Stall speed 323
But
kilometers.
the stall speed is 320 kilometers. That's the current state, which is caused by the flaps being lowered. There was the information about the flap positions higher up.
Left positions 0/4.
And it says flap positions 0/4. That means that the flaps are currently at position 0, which means they're not raised at all, but the maximum position to which they can be raised is 4. So because the flaps are completely lowered at the moment, that's why the stall speed is so high. It's comparatively higher than either the landing speed or the takeoff speed. We wouldn't be able to take off at all with the flaps set to this position. As soon as we raise the flaps, the stall speed is going to get lower. We can even try it out. I'm going to leave the properties window for now. But one more thing that I need to mention before doing that
Dashboard window
is that the first ever thing we always need to do before doing anything else with the plane, before starting any other systems, is to turn on the power supply or the battery. And that is done with the keystroke Control-Shift-B for battery. because all the systems need some power in order to be able to work at all, and only in this case, when the battery is on,
Set flap position. Set flap position edit blank.
we can start using or working with the flaps. I'm going to raise the flaps to position 1.
1. Dashboard window.
Flaps set.
And we'll see that the stall speed has become lower now.
Current stall speed 233 kilometers.
So the stall speed is at 230 kilometers now, which is already lower than the takeoff speed. So we would now be able to take off successfully. The current takeoff speed
263 kilometers.
is 263. It says current because this takes into account the current weight of the plane, our existing fuel load, all the passengers that we may have on board. And that's why the current speeds, as well as the current weight of the plane, can be different, can be higher than the base values.
Takeoff nose angle 7 to 12, 18.
Takeoff nose angle 7 to 12 to 18, or 7, 12, 18. There are 3 values here which refer to the minimum possible, the ideal, and then the highest possible nose angle that we can have when attempting to take off. Every plane requires a different nose angle, and that's why it's important to know or to take a look at how much we need to lift the nose in order to be able to take off.
Minimum flap position when taking off 1.
Minimum flap position when taking off 1. This is the very line where we can learn the minimum required position that we need to raise the flaps in order to even be able to take off at all. The position of 1 does not mean that we would not be able to take off with a position of 2 or 3. Yes, we can, but 1 is the minimum required position. At the position of 2 or 3, we would be able to take off, but the required length of the takeoff runway would get longer.
Minimum takeoff runway length 2,900 m.
Here we can find out what the minimum required length of the takeoff runway is for this particular plane, and this takeoff runway length is calculated using the maximum possible fuel load and the maximum possible number of passengers on board, meaning under the maximum possible load with the maximum possible weight of the plane. So this is really the overall total required maximum under any possible conditions. We could actually take off even on a much shorter runway if we were flying, for instance, with an empty plane. Next, we can find out very similar information about landing.
Current landing speed 263 kilometers. Minimum flap position when landing 3. Minimum landing runway length 2,150 m.
The landing speed is 263 kilometers per hour. Minimum flap position when landing is 3. That means that in order for us to be able to land successfully, the flaps have to be raised at least to position 3 to even reach the required landing speed. Because if we did not use the flaps, we would actually enter a stall and start falling before we would be able to reach that low of a speed. And we need over 2 kilometers of runway in order to land, and then stop and brake all the way to a full stop before we would run out of the runway and crash.
Fuel tank capacity 56,520 L.
Capacity.
Current fuel load 0 L.
That means how much fuel we can get in total.
Current fuel load 0 L.
And current fuel load is 0 liters, which means our tank is completely empty at the moment.
Current range 0 kilometers.
Current cruising range 0 kilometers with the current fuel load.
Fuel used 0 L.
And fuel used 0 liters. We haven't spent any fuel yet. So these have been the properties that discuss the plane's parameters when it comes to taking off or landing. And now we are going to get started with the various systems on board. The first thing is the current status of the power supply of the battery.
Battery on.
And it's on because we've already turned it on manually because we needed it when manipulating the flaps. So the battery is the power supply that provides power even to the most simple systems of the aircraft. We would not even be able to raise the flaps at all without the battery being turned on. So we always need the battery. We can't even turn the radio without the battery. So we always need to turn it on.
APU off.
APU is a system which provides more power, and that is necessary in order for the engines to be able to start. Not all the planes have this. The smallest planes of category 1 don't even need an APU at all because they're able to start the engines on a battery alone. Large planes which have large engines cannot start them on battery alone because the battery does not provide enough power. The power supply is not sufficient, and that is why they need this APU unit, which is a power source for the larger, more demanding systems and for the engines. Even some other systems, such as the TCAS or the temperature control, may require more energy in order to be turned on successfully. You may not be able to turn them on battery alone. So that's why if you're not able to turn a particular system on, it may be for the reason that you need to turn on the APU first. It works in such a way that the first level of providing power is the battery. Then if the plane does have the APU unit, it is this system that you need to turn on next. And at the very end, it's the engine or engines themselves. So the engines provide the most power, the battery provides the least power. We can currently hear that the APU is turned off, and it's turned on or off with the keystroke control page up.
Engine 1 off.
Now we have information about each engine separately.
Engine 2 off. Engine 3 off. Engine 4 gear 1. Engine 4 off.
We can see that this airplane, the Airbus 380, has 4 engines. So that's why we can see the lines that say engine 1 off to engine 4 off. Every plane has a different number of engines, and we can turn the individual engines on or off with the keys. Page up for engine 1, then page down for engine 2, then it's alt page up or alt page down for engines 3 and 4, and we can even have keystrokes alt shift page up and alt shift page down, because there are some planes that do have even 6 engines. Each of the engines can be running at a different level of power, and that is what we can find out here in the airplane properties. Now we're told about the gears. What are the gears? In Eurofly 3, when working with the engines, which I'm going to be demonstrating in a later part, we're actually working with the power of the engine. That means that the engine can be running at full power or at a minimum power or at a quarter or half of its maximum available power. We are not setting the actual desired speed because the speed is only the result of the power. If we set the engine to full power, then it's going to be providing full force, and that is going to make the plane reach a certain speed. Obviously, if we now started only one of the 4 available engines, then the resulting speed would be lower than the maximum possible speed. And if we started 2 or 3 out of the 4 engines, it would naturally get higher. So working with the engines also has to be well considered. And we can not only increase or decrease the power by 1% every time or by 10% every time, but there are also gears or throttle presets actually available to us. And the gears are something similar to when you imagine how you may be shifting gears in a car. We increase or decrease the engine power with the home and end keys respectively. In that way, we always change it just by 1 every time. If we add shift to the home or end keys, then we increase or decrease it by 10% on each key press respectively. And by pressing Alt Home or Alt End, we set the engine to maximum power or to 0 power respectively. Or we could use Control Home and Control End, and in that case we would be switching the presets. They are listed in the properties now.
Gear 1, 0,1%, 2,4%.
So if we're running at gear 1, there's a range of 0.1% of the maximum engine power.
And gear 1, 0,1%, 2,4%.
2.4% of the maximum engine power.
Gear 2, 2,5%.
Gear 2 is between 2.5%
Gear 2, 2,5%, 4,9%.
and 4.9%.
Gear 3, 5%, 7,4%.
Gear 3 is between 5% to 7.5%.
Gear 4, 7,5%, 9,9%.
and so on.
Gear 5, 10%, 10%.
And let's talk a bit about the engine modes at this point, because you may have noticed that it doesn't even mention like 50% or 100% of the maximum engine power at any point. We can't see any higher level of power than 10%. That's because the Airbus A380 is a very large plane, and if we were taxiing along the airport with it, it would be very difficult for us to work with the engines, because this plane's engines are also very large and thus very powerful, and the airplane is able to reach a very high speed quickly. That's why we have 2 engine modes available in planes, and these are the flight mode and taxi mode respectively. I'm going to leave the properties again.
Dashboard window.
And we can switch these modes with the Shift Delete key.
Flight mode. Taxi mode.
And with a delete key on its own, we can always take a look at the status of the engines. But we need to have the onboard computer turned on first for that to work. So let's turn the onboard computer on with the keystroke Control Shift K. So if I'm now going to turn on the computer.
Computer on.
And press delete.
0, power, 0%, gear 0, taxi mode.
And we heard 0, power 0, gear 0, taxi mode. Imagine that you're controlling the engines by moving a lever. So that first number refers to the status or to the position of that lever. You can move the lever anywhere between positions 0 and 100, and each one of these positions will result in a different power, different output, if you will, for the engine. Currently it's set to 0, as well as the engine power itself. Now if we put the lever to 100, meaning to the very maximum in this mode, in taxi mode, we'll only raise up to the power of 10%. Out of the engine's maximum 100% actually. That's what we saw in the properties. And that's because we are currently in taxi mode. So in practice, gear 5 in taxi mode would only bring the power up to 10% of the engine's maximum possible power, which essentially means that we'll be taxiing along the airport at an acceptable speed. So the taxi mode lets us control the airplane while at the airport in a safer and more comfortable way. But if we now press Shift Delete,
flight mode,
and if we now put the lever to 100, then that would already result in the maximum actual possible power for the engines. And if we did this at the airport, like say in the hangar, that is really not what we want, because that would then result in us really picking up speed and momentum and being literally unstoppable. so that we could easily crash in the end. And that's why there are two flight modes. But we'll now get back to the plane properties.
Combo.
And let's pay attention to what's displayed for the gears now.
Gear 1, 0,1%, 4,9%. Gear 2, 5%, 26,9%. Gear 3, 27%, 48,9%. Gear 4, 49%, 70,9%. Gear 5, 71%, 89,9%.
So gear 1 gives us the resulting power up to 5% or 4.9. Gear 2 produces power from 6% up to 26% essentially. Gear 3 goes from 27 up to 49%, so that's almost half the maximum possible power already. Gear 4 essentially gives us the power between 50 and 71%. Gear 5 from 71 to 90%. And Gear 6 from 90 to 100%. So this large plane has 6 gears available. So what this means in practice during flight is that if you ever needed to slow down to a certain speed, you could easily just, set the engine power to drop a gear, or on the contrary, to just shift up by 1 gear, rather than having to manually set the power by 1% on each step. It's necessary to say that Gear 1 is usually the one that already results in a stall, meaning that we should never be flying on Gear 1 while actually airborne. Or even if we do, we should just be watching out for the speed at all times and to the way that it drops. And at the moment it gets dangerously close to the fatal stall speed, we should speed the plane up again, at least to Gear 2. At least Gear 2 is needed in order to keep the plane airborne. But on the other hand, engines are never used at 100% of their power. So Gear 5 starts at 90% of the power. So if we set the engines to Gear 5, they'll be working at 90% of their maximum possible power, which is the optimal performance for a prolonged flight. If we do set the power all the way to 100%, we can do that. But after a while, we'll be prompted by the plane to lower it below 100, because if we kept it at that, we could damage the engines. And if we keep going at 100% of the power for too long, we will damage them. So it's just not suitable to be flying at 100%.
Reverse thrust inactive.
The next system we have here is reverse thrust. Reverse thrust is what causes the engine to work in the exact opposite way, so to speak, meaning that it would then make the air flow in the opposite direction than normal, which would result in us actually braking or dropping speed. Reverse thrust is used after a successful landing in an airport when we need to actually slow down and stop, because when touching down, the engines are not working at that very moment. We must have stopped them before in order to be able to touch down successfully and not crash. So they're now running idle. And at this moment, when they're running idle and we've just touched down and are taxiing along the runway, that's when we can turn on the reverse thrust and essentially reverse the performance of the engines to make them work in the opposite direction, so that they then slow the plane down. But never turn on reverse thrust while airborne, because that could result in a fatal stall as well. It would just result in you losing engine power.
Doors closed.
The doors, these are the cabin doors. They can either be open or closed.
Cockpit open.
Same for the cockpit doors.
Belt unfastened.
This is referring to the seatbelt that we ourselves as the pilot use. That can, of course, be either fastened or unfastened.
Parking brakes active.
Parking brakes. These are different brakes than the ones that are used for landing. These brakes you apply and you activate them when you're already standing at a full stop to make sure that the plane does not move by itself. We can't move while they're active or while they're engaged. So if we're standing still at the parking lot or in the hangar, we need to disable them first before we can start moving again. We call them parking brakes because the plane obviously also has another set of brakes, normal brakes, the kind that you would expect, which are used when landing or when trying to stop right in place at a gate or at a stand, etc. And these are activated with the slash key, so right next to the period key on your keyboard. As long as you're holding the slash key down, you're actually stepping on those landing brakes. It works just like an actual pedal would in real life. If you were in a car and you just tap the brake pedal briefly, you would not be able to slow down all the way to full stop. You would need to keep holding it down too.
Landing gear raised.
The landing gear can obviously either be raised or lowered.
Flap position 0.
And flap position 0. So this tells us, remember how I was talking about the flaps before, and this is referring to the position that the flaps are set to at the moment, right now. If they're at 0, like they are in this case, it means that they're not raised at all.
Onboard computer on.
We have turned the onboard computer on before, so that's why it's on.
Radio off.
Our radio, which we can use to contact the tower, is currently off.
Transponder off.
The transponder is a system which identifies us while flying, while airborne. If it was on, it will say the value that we have set it to here, instead of saying off. That's why when we begin the flight, the tower is going to assign a code for the transponder to us that we have to enter into the transponder. From that point on, we don't actually need to work with the transponder anymore, but it has to be turned on all the time, because if it's not turned on or if it's not set properly, we might run into issues, into problems while flying, especially when entering the airspace of a foreign country.
Communicator off.
The communicator is used to talk to other pilots. I'll be talking about it more in a separate part. It's currently off.
Atlas off.
The Atlas is also currently off, and it's a system that we can use even while flying to browse the map if we need to look up a location before we actually reach it or something like that.
Sensor off.
The sensor is a system that allows us to keep track of as we're taxiing along the airport, along a taxiway or runway, to see whether or not we are getting too close to the edge of the taxiway or runway. Each runway or taxiway has its direction, its width, its angle. So if we're taxiing and trying to turn towards a new taxiway, we could then easily get too close to one of its edges, which would then cause us to actually leave the taxiway as we're gaining speed, which is something we don't want to happen. So we want to keep the proper direction at all times, and the sensor is thus letting us know by beeping how close we're to the edge of the taxiway. The faster the tone, the closer we are to the edge, or if the tone starts playing continuously without any interruptions, that means we are already at the very edge of the taxiway. It's important to realize that the sensor is not actually informing us about what's ahead of us, like it might do, for instance, in a car. But it's only telling us where we are currently located on the taxiway. That means that if I'm taxiing along the taxiway and the sensor starts beeping in the left speaker or earphone, that means that I'm getting very close to the left edge of the taxiway. If it's beeping on the right, I'm close to the right edge. You may, for instance, find yourself in the situation where you've just entered the hangar, you've closed its doors behind you, and the sensor starts beeping. It's not beeping because there's something in front of you, because essentially there's nothing ahead of you. The hangar doors are behind you when you've entered it. But the sensor is beeping because you're located near the edge or near the hangar wall, even if that edge is behind you. If it did beep in the center, that would not mean that there's an obstacle in front of you, but rather that you are approaching the edge of the space that you are currently moving in. The edge could be either ahead of you or behind you, as in this case, of just having entered the hangar. So that would mean that you would need to either move a little bit more forward or backwards, respectively. But this situation where the edge of the area is directly dead ahead or right behind you can only occur while standing in a gate or in the hangar. Otherwise, while moving along taxiways or runways, the sensor can only ever beep either on your left or on your right.
Status monitor off.
The status monitor is a system which allows you, while using a braille display, to configure which values or which pieces of information about the airplane you would like to be able to see at all times on the braille display. You may want to set it to display your current course and altitude and speed at all times, for example. And if you are a braille display user, this can be faster and more comfortable than having to find that information out with a key press every single time you need it and having to listen to your TTS reading it out, because that can get annoying or cumbersome. There are 4 types of lights in the plane.
Taxi lights off. Cabin lights off. Strobe lights off. Landing lights off.
And as their names imply, they're all used in different situations. The taxi lights we only turn on while taxiing along the runway. The landing lights are used only when actually touching down for the landing. The cabin lights are used so that the passengers can see what's around them while they're sitting in the cabin. And the strobe lights are outside of the plane, so essentially we keep those turned on at all times so that like the airport personnel or other planes flying nearby can see that we are actually there.
Ventilation off.
Ventilation is the system which is responsible for generating oxygen on board. It's especially necessary when flying at a higher altitude, so that's why the smaller planes may not even have this system at all, because they wouldn't need it, as they can only reach lower altitudes where there's enough natural oxygen in the air as is. But if we climb higher, say to an altitude of several kilometers, we may cause our passengers to not have enough oxygen if we did not turn on the ventilation.
Cabin pressurization off.
Cabin pressurization is a similar system. This is responsible for always making sure that the pressure in the cabin is always sufficient, again, especially at higher altitudes.
Temperature control off.
Temperature control is another system. This one keeps the cabin warm at all times, so essentially it acts like a heater. But in the case of this system, it's not enough to just merely turn it on or off, but when we want to enable it, we also have to set the expected temperature that we would like to have on board. If we now turn it on,
Dashboard window.
I had to press Control page up first in order to turn on the APU, because the temperature control is a system that already requires more energy than just the battery on its own can provide.
Temperature control on.
Let's now take a look at the properties again.
Combo box. Transport. Takeoff. Transponder. Taxi light. Temperature control. 12/18C.
And we can see that it's currently turned on, that we have the required temperature set to 18 degrees, but the plane is still currently heating up in order to reach that temperature.
Temperature control. 12/18.
So it's currently at only at 12 degrees at the moment. We can also change that temperature
Dashboard.
if we leave the properties window again and press Alt Q.
Set temperature. Set temperature. Combo box 18 collapsed.
So let's set it to
22.
22.
Temperature
Dashboard window.
set.
Temperature set. And now if I take a look in the properties again,
Combo. Taxi lights. Temperature control. 14/22C.
it's currently at 14 degrees, but it's going to go all the way up to the 22 that I just set.
Storm radar off.
The storm radar warns us of the vicinity of storms as well as their direction.
TCA off.
Well, yeah, the synthesis pronounced it wrong, but the TCAS is a system that warns us of imminent collisions with other airplanes.
Stall indication off.
The stall indication is a system that warns us if our current speed is too low and we are about to enter a fatal stall.
GPWS off.
GPWS is not GPS, used for navigation, but GPWS is essentially an anti-crash radar. It would warn us of obstacles that were in front of us, like if we were approaching a mountain and we were about to crash into it if we did not climb higher, or if we're descending too low and are about to hit the ground. If we're about to hit the ground, this system would warn us to climb, and if we were about to hit an obstacle like a mountain ahead of us, it would advise us to change course.
Bank angle indication on.
The bank angle indication is the system that tells us every time when we are banking in some way, which means that we are not flying straight. It could either refer to the nose being raised or pointed downwards, or to the wings or wheels, meaning whether we are currently turning while airborne or while on the ground. I'm now going to lift the nose.
Dashboard window.
And we can already hear this kind of indication, which is telling us that the nose is not level. And this is especially useful while flying because it's easy to press any of the arrow keys, even by accident. So using this system, we'll always be able to tell at any given time that we are not leveled and we're banking in some way.
Combo box. Airbus APU, Atlas off, audio navigation off.
Audio navigation is the system that indicates with a sound where our current destination is in relation to our current position and course. So if we put, say, Berlin into our navigation, we would then be able to hear, because of the position of that audio, of those beeps, whether Berlin is currently to our left or to our right or dead ahead.
Auto navigation off.
Navigation is the system that guides the plane towards the selected waypoint or destination automatically. So this is essentially part of the autopilot.
Auto speed inactive.
Auto speed is a system which lets us set the targeted or the required speed, and let's say 260 kilometers per hour or 500 kilometers per hour, and the plane would then speed up or slow down respectively in order to maintain that required speed.
Auto course inactive.
Auto course lets us set the required course in the same way. So if we want to turn, say, to 50 degrees, we would just set it here and the plane would turn by itself and we would not have to do it manually.
Auto altitude inactive.
And the same goes for the altitude. We can also set the altitude that we want here and the plane would then climb or descend accordingly by itself. If we are using these automatic systems and we then press, for example, the R key, which reads out our current speed, or S, which reads out our course, it'll say the value and then it will also say the word auto, which indicates that we have set the value for the plane to maintain automatically. If you feel like there are too many of these systems and too many keystrokes to control them, and it's just not possible to remember them all off the top of your head, let me remind you once again about the help feature that I was talking about in part 5, where I covered the additional features of the world map exploration mode. You can always turn the help on or off at any time with Alt-H, even during flight. Alt-H for help. So it's useful to remember this. It works exactly in the same way as I was demonstrating in part 5 of this series. The only difference is that it's also contextual. So it's always only going to show the systems that the particular airplane that we're controlling actually has. So for instance, it wouldn't show you the keystrokes for the APU unit if you were flying like the Cessna C-172, which is a small airplane of category 1, and it doesn't even have an APU. It only has the battery and a single engine. So it would not show you the keystrokes for engines 2 to 4 or even 2 to 6 at that moment either. Also, the sounds overview is different. It's now obviously going to play the sounds that you can hear while flying, not while exploring the map, because we're not in map exploration mode anymore. And the last edit field of the window, that is kind of a text guide telling you or pointing out all the various actions that you can perform with the plane, is going to be contextual and is going to be different than it was in the map exploration. So that's it for today. Thanks for your attention, for listening and for sticking with me. And stay tuned for part 8, where I'm finally going to show you how the plane is actually controlled.